Okay, so now we are going to go over some examples from chapter 1 to make sure we are ready to apply all the literature that and all the rules that we learned in previous videos. So this will complete your chapter 1 video sessions. Okay, so right here, these are very similar to the homework. I have received several questions about the homework. They are end of chapter homework problems. So for chapter 1, I think it's on page 20 where you're going to start, and the way you read the homework assignments is as follows. Example 1.1. So if it says 1.1, that means chapter 1, problem number 1. Keep in mind that some of the problems have A, B, C sections to it, so you have to do all of them unless otherwise specified. So let's start with the example here. It says convert to engineering notation. Engineering notations means multiples of 3 for the exponent, and you can have up to 3 digits to the left of the decimal point. So right here I have a non-zero value, a zero value before to the left of the decimal point, so that's not engineering notation or scientific notation. So I'm going to take it to engineering notation. So how many places I have to move the decimal point to the first non-zero value? So let's count them. 1, 2, 3. So it takes 3 places for the decimal point to be moved for the first non-zero value. So I write it and then I say times 10 to the 3, and it is negative because I'm moving the decimal value to the right of it. Okay, so I'm making a small number into a larger number. That's how you know that it is negative. So I'm making, that's the representation. And now I have to check, is 3 a engineering notation? Yes, it is, because it is a multiple of 3. The second part, I have 0.00033. So now I'm going to count how many times or how many places I have to move the decimal point. So I'm going to move it 1, 2, 3. Thinking that it has to be a multiple of 3, I can write as 0.33 to the power of negative 3. But this is incorrect. Why? Because the 0, you cannot have a 0 to the left of the decimal point. It has to be positive but non-zero value. So we have to continue here. So right here we are going to move it until we get the first non-zero value. So it's going to be 1, 2, 3, 4. 4 is not a multiple of 6, so I have to continue. 5 and 6. 6 is a multiple of 3, so I can stop. So my actual engineering notation value representation of this number is going to be 330 times 10 to the power of negative 6. Let's continue. Now we are going to go into metric conversions. That's example 1-13. So in the metric conversions is where we have some letters associated with some prefixes. We call it prefixes, they mean something. So we have 0.15 milliamps, and they want us to take it to microamps. Okay, so we know that milli is to the power of negative 3 and micro is to the power of negative 6. So we are going to go from a large value to a small value. This is just, I do it for me to keep track of what I'm going to do when I multiply it. Where does the value stay? Do I multiply or do I divide with the small, with the value that I'm doing the conversion? So I have 0.15 milliamps. So since I'm going from a large to a small, I know that 1 milliamp has 1,000 microamps. The difference between 6 and 3, it's 3. So that is 1,000. So I get rid of the milliamp units and I get microamps, and now I'm going to multiply that, and I'm going to get 150 microamps. It's important to know to follow the instructions. Here they didn't tell us that they want it in engineering notation, but since they are already giving it to us with the prefixes that are associated with engineering notation, we must put it in the correct format, okay? Let's move on. Example 1-14 is giving us 4,500 microvolts, and they are telling us to take it to millivolts. Microvolts is to the power -6 to millivolts, which is power of -3, so we are going from a small to large. Okay, so since we are going from a small to large, instead of multiplying, we are going to be dividing. So we have 4,500 millivolts, so 1 millivolt has 1,000 microvolts. So we get rid of the microvolts here, microvolts there, so we are left with millivolts. We put it in our power of 10 format, so we don't have to use a calculator. So 4.5 to the power of 3 is equivalent to 4,500. 1,000 is equivalent to 1 to the power times 10 to the power of 3. So the 3 minus 3 becomes 0. 10 to the power of 0 is equivalent to 1. So that's why we don't have it right here. Okay, let's move on. We have another example. This is similar to the homework. It says add two values and express result in engineering notation. I put number, it should be notation here, okay? So I have 3.6 times 10 to the power of -3 plus 7.5 times 10 to the power of -2. The first step, if we go back to the previous video, was that we have to make the power of tens to be the same exponent. So we have 3 and we have 2. So we have to decide which wanted to make it. Which we choose, 3 or 2. I did 2 because I wanted to show a point right here. So you can do 3 and it's equivalent. So 0.36, I'm going to bring it down to -2. So I'm going to move the decimal point to the left of it. That's how I reduce a 0 on it, okay? So it's 0.36 times 10 to the -2 plus this remains the same. So the second step was just to add the values without their base of tens. So 7.1 plus 0.36 is equivalent to 7.46 times 10 to the -2. But we are not finished here. We have it so far in scientific notation. They are asking for engineering notation. So we are going to go ahead and one step farther. I'm going to move the decimal point to the right one more time. So I make the 2 into a 3. So my value is actually 74.6 times 10 to the -3. That is engineering notation. Or I can use the prefixes and say 74.6 millis. With multiplication is the easiest of all. Here we are just going to multiply the numbers, 32 by 56. I'm going to get 1,792, and then I'm going to add the exponents of it. So -3 plus 3, it is a 0. 10 to the power of 0 is equivalent to 1. So my value would be just 1,792. But they are asking for engineering notation, so I have to make sure that I can only have 3 values before the decimal point. Right here I have 4, so I have to move my 0 one time, but if I move it one time, it's going to be to the power of 1, which is not engineering notation, so I have to move it 3 times so that it satisfies both conditions. Less than 3, and the exponent it is to the power of 3. I can use power of 3 or I can use the prefix k. Divide is the same thing. For divide, I divide the numbers and then I subtract the exponent. The numerator exponent by the denominator exponent, and then I get my result. And here is not engineering notation because I have a non-zero. I have to make it into engineering notation as I did and it's shown right here. Okay, metric conversions. we do a section of that, so we are going to go 5,000 kilovolts to megavolts. We are going from small to large again, housekeeping here. So I'm going to have to divide. So 5,000, 1 kilovolt, 1,000 kilovolts are equivalent to 1 millivolt. So the kilovolt and the kilovolt cancel, and then I move on. I write in the exponent format. I get rid of the exponents, and I end up with 5 megavolts. And those are the examples right here. We conclude chapter 1 with this.